Hi everybody. In this video, we are going to explain the basic signal operations. It's given the signal x of t, which is continuous time signal, and it's defined in this graph. It's equal 0 when the time is less than -4, and from -4 up to 0, it's a straight line, and this straight line with a slope equal to 1, and the equation is t plus 4. And from 0 to 6, the signal is constant at the value of 4 and 0 otherwise, to the right, to the left. Let's now perform the first signal operation, which is called time shifting. Time shifting could be to the left or to the right, or sometimes we call it delayed and advanced. The first one, xt minus 2. When you say xt minus 2, it means the whole graph is going to move 2 units towards the right. Let's see how can we do it in this one. You pick the most important point. The most important points in this graph, -4 and 0 and 6. Between -4 and 0 is straight line. This straight line is going to move 2 units to the right, so -4 becomes -2 and 0 becomes 2. So the graph will be like this first part, it move in this part, and the 0 will be in this one. And then this constant value 4, it's from 0 to 6. So it's going to move to 2 and 8. So from 2 up to 8. So that will be the function here. And after 6 will become 0, but no, after 8 will become 0. So that's the graph. Well, what happens if we want to do x plus 2? So now x of t is given, and we want to do the other shifting, x t plus 2. When you say x t plus 2, it means the whole graph is going to move 2 units toward the left. Let's just see that. At 6, it will go to 2 units to the 4. So it'd be like that. And this line, which is 4, equal 4, between 6 and 0, it will move to 4, 6 will move to 4, and 0 will move to -2. So it will be like up to t corresponding to 2, -2. And then this straight line between -4 and 0, 0 becomes -2, and -2 will become -6. And then it will become 0. So as you see, the whole graph moved 2 units towards the left. Observe, no change in the magnitude, only shift in the time. That's called time shift. Now, the second operation is called time scaling. And time scaling when you multiply t by a constant a. If a less than 1 and greater than 0, it means you have a positive number, but fraction, what happened, we call it expansion. And if you have a greater than 1, like 2, 3, 4, 1.5, something greater than 1, this process is going to be called compression. Let's take one example. We'll take the compression first. Compression a is greater than 1, like 2. So we say x of 2t. That's x of t given. As you observe here, it's like a triangle shape, and it's 0 if the time less than -2 and 0 when the time is greater than +2, and the height is equal to. So when you have x to t, what's happened? You divide every point here on the time by 2. Remember that. So 0 when you divide it by 2 becomes 0. The same thing, the height is equal 4. And -2 divided by 2, it will be -1. So this point, -2 becomes -1. And the point 2 divided by 2 becomes 1. And you connect your triangle here. And would be 0 to the left and the right. So as you see, it's having compression to this graph. All right, let's take the expansion. When alpha is a fraction, positive number, like x 0.5 t. In this case, you multiply everything by 2, the opposite, because it's like 1/2 t. You make it double. So -2 will becomes -4. And 0 times 2 be 0. the value is 4. And at 2 becomes 4, and the value is equal 0. 0 to the right, 0 to the left, and then you connect your triangle. And you get the expansion for x 80 when a is less than 1. The third signal operations is called time inversion. And time inversion, when you put negative sign in front of t, it means if you want to find x of negative t, well, in this diagram, x of t is given. It has to part here, 0, and then go to negative 1, go up from 0, straight line, slope equal to 1, up to 2, and then go back again to 0. It's very simple one. X of negative t, it means reflection on the vertical axis. So this part, this triangle that you see to be reflected there with the same magnitude, just the time will be flipped. Like 2 becomes negative 2. And this square to the negative will be reflected on the y-axis at negative 1. Instead of negative 1 becomes 1. The time will be just change the sign. And that will be the inversion of the signal. So it's a very simple one, and it is just the reflection on the vertical axis. Okay, now let's have a compound operation. It involves more than one operation. It's given x of t, a continuous time signal shown in this graph, and it's required to find x of 0.5t minus 1. So this function or this signal has two operations. There is one 0.52 will be expansion, and negative 1 it's time shifting towards the right. So what is the order? You can do it from any order, but just I would prefer to start with the time shifting. So there is time shifting by 1, and since negative 1 it will be towards the right by 1 unit. So every single point is going to move to 1 point toward the right. As we did in previous example, 2 will go to 3. So that's 2 will become 3. And 1 will move to 2. So now we have the first part moved by 1. And this straight line with the slope 1 from 0 to 1, it will be from 1 to 2. And this little square, negative 1 add 1 be 0. So it starts from 0 up to 1. Okay, let's just make a nice straight line. And then just we'll make it 0 to the rest of the graph. So what we did, it's just with it shifting like by 1, we did x t minus 1. Now, after done with time shifting, we'll do the second one, time scaling. On time scaling, every t is multiplied by 0.5. It means we'll have expansion. So you are going to multiply every point by 2. So let's pick the first point. This is 3 multiplied by 2 will be 6. And 2, when x equals 2 multiplied by 2 be 4. So you have these 2 points. Between these 2 points, 2 and 3, you have a straight line equal 1. It will be equal 1. But just not instead of between 2 and 3, it will be between 4 and 6. And of course, you can complete the graph. It is 0 to the right, no change in it. Now, the second part, it's from 1 to 2. From 1 to 2, it's straight line with slope equal 1. So instead of 1 multiplied by 2 will be 2, and 2 it becomes 4. And that will be the straight line. All right. Now, between 0 and 1, you multiply 0 is still 0, and 1 becomes 2, and then you have the value is equal to negative 1 of this function. And 0 to the rest. So that's the will be the results of the compound operation. I hope that was simple. Okay, let's have one more example. How can you express a signal in terms of unit step function? We have in front of us here a rectangular function, and it's defined by a rectangular t over 4. T here, it means t minus 0, it means there is no shift, so the axis of symmetry of the rectangular pulse, it's at t equals 0, and the width is equal 4, it means like 2 to the right and to the left, so it's from negative 2 to positive 2 and 0 otherwise. How to express this rectangular pulse as function of 2 unit step? Very simple. First, you can say you have step function start from negative 2 and continue. So that's u t plus 2. It's a step, but shifted to the left by 2 units. So it start from negative 2. You can write this one, u t plus 2 is equal to 1 when t is greater than or is equal to negative 2 and 0 otherwise. And you have another step, start from 2. Will be 1, and when time is less than 2 will be 0. This function is unit step, ut minus 2. Unit step shifted towards the right by 2 units. So now we have this 2 unit step. If you subtract from each other, if you say I want to find ut plus 2 minus ut minus 2, both are step function. The top one, ut plus 2, minus the one in the bottom. So let's just go ahead when you subtract. When you have that's 0 minus 0, you will have 0. All right. So that's 0. And from negative 2 up to 2, just make a line like that. So when you subtract, this is equal 1 and this is equal 0. So 1 minus 0 is equal 1. That's from negative 2 to 2. And then from 2 to infinity, 1 minus 1 is equal 0. And here you go. You got the rectangular pulse. So you can say that rectangular pulse t over 4 is equal to t plus 2 minus u t minus 2. And that's it for this